Look at this tree pattern. Do you realize that there is a very clear left turn to this whole thing? Let's see this more clearly by comparing this to the base tree. Let's say this. Now, this is what we are building in the last video. Notice this tree looks very symmetric, very balanced. But when I compare to what I'm showing you now, very clearly you can see that, look, there is a turn leftward. If I just compare, it is extremely clear. In fact, this is happening because we are coding our new tree in a special way. Remember, in this tree, basically it's all y's connected to each other. But then, I made an equal angle when I went to the right side as I went to the left side. But what I'm doing now is quite special. I am making a smaller turn to the left, to the right compared to the left. So basically, my right side angle is 20 degrees, whereas my left side angle is 30 degrees. And clearly, taken together recursively, this ends up creating the tree, but the tree has a very clear leftward drift. Of course, we could have done it other way. We could have created the right side drift as well by making the right angle, more than the left angle. So the point here is that now we are dealing with not one angle, but in fact two angles, and making the tree, let's say, more interesting, right? So obviously we are enhancing the fractals and recursion project from the YByte Python curriculum available at www.ybyte.in. Let's see how we can get this done in this video. In fact, this is quite interesting because this really makes us think about how the turtle is actually moving, exactly what's going on, especially at the base case. Let's, however, approach this step-by-step manner. Let's first understand what is our goal. Like I said, in the class project, basically my angle to the right and angle to the left were equal. I just denote them by A over here. Hence, I got a very symmetric looking tree. But now I'm saying that, look, angle to the right is perhaps A, but angle to the left is, say, B, where B is more than A. Like, this is just arbitrary. It could also have been A is more than B. The tilt will accordingly change, right? But the important point, like I said, is now we have two variables, angle left and angle right, which are not equal to each other, as against this, where we just dealt with, let's say, one angle. Now, remember that when we are building this whole game, or let's say this whole drawing, when we basically make a right drawing first and then come to the left drawing. However, in the way the code is written, after doing one drawing, in fact, we turn a little too much to the right. For example, I'm aligned this way. This line is shown dotted because we are never going to draw it. However, I'm going to bring my turtle back, which means I must realign, I must bring it back, and then I must turn it again to go and draw the left side. So we have analyzed this in a lot of detail previously. Let's take a specific example specifically at the base case, because that's when it becomes very clear. Now, let's say we have angle right and angle left both 20. So, I, let's say, do 102. So obviously that goes and draws the level 2. It calls level 1, which is branch 81. So that is this line. I move forward 80 steps, so assume this is 80, and I turn right by 20. And this is what I mean by saying that we are turned too much to the right. Now, we have talked about this before. Now, at point A, I'm turned 20. Now, remember, I must align myself. So I do it in two steps. So, I first go minus 40 to this side. Notice t dot right minus 40 is basically saying t dot left 40. So I kind of overdo this on the other side, and then I bring it back again, right? Now, this may look a little bit roundabout, but think about it. I must align back, I must come back here. That's when this statement comes in. At this point, I do need this minus 40, because remember, having aligned this way, I must go, let's say, 20 this side and then 20 that side. So I must actually turn 40 degrees in this case, or two times angle in general. So that's why I do need this statement. And when you work backward recursively, you will find that in fact this is the solution. Now, we actually spoke about this, but think about this. Really beautiful and really key to understanding how this is actually working. Now, what's happening now is that I have angle right of 20, let's say, still, but angle left, for example, becomes 30. Now, in this case, once again, when I trace back, so this should have been t dot right 20. That's my mistake here, because this is 20. So this also is 20. So I'm again, same thing, nothing changed here. I am too much to the right. However, what I'm going to do is, remember, I must again align back to this, but it will happen two steps. I will, instead of going two times angle of right, in fact, I will, in a similar spirit, again, I'll go minus, let's say, left plus right. So I'll go minus 20 plus 30, which means if I compare these two, I've kind of over exaggerated this. I have, in fact, turned more now. So, if I, let's say, compare the original situation to now, you can clearly see I am turning more. Of course, I'm exaggerating this whole point a little bit. But having done this, remember, I must realign. And the way that will happen is that, well, look, I had gone this was 20 too much to this side. I went 20 plus 30, so I'm 30 this side. If I turn by 30, I'll come back here. I will come back to this point, and then I must, in fact, remember this is, from a vertical here. This side is 20, this side is 30, so I must turn 20 by 30 on here, right? So if you think about it, it's basically a generalization of what we were doing earlier. The idea is exactly what is depicted here. In more general terms, I will say that, okay, look, instead of turning right by angle alone, I'll turn right by angle R. Then, when I go on the left side, I'll go by angle minus angle R plus angle L, which is kind of, becomes equal to this if both of these are equal. However, to realign myself, I'll move right by angle L. Again, if you can see that they're all actually equal if angle R and angle L are in fact equal. That's all we need to do. So I get back to my code. Now I'm going to define a couple of variables. Let's say angle R is say 20 and angle say L is, let's say, 30. Just some numbers. Now remember, when I do this, I'm not going to move this. So 20 is hard coded over here. I'm going to say, well, move right by, let's say, angle R. Next, I have got turn left, which is same as right minus. So I can just use turn left. That's okay. But I am going to do turn left angle R plus angle L. We discussed about this. And once I come back here, I will go and do turn right by, let's say, angle L. So, we have discussed this before. This is exactly what we're doing. The only difference is I was using T dot right, but then I had a negative over here. So that's the only difference. Apart from that, I think this should be okay. So when I run my code, I ran this with the tracer being set to 0. So I immediately got the output. You can clearly see that now there is a turn leftward. In fact, we can exaggerate this by saying that, okay, let me try to make maybe my, right, let's say right, let it be 20. Let's make left, say maybe much bigger, say 50 degrees, right? Now, when I run this piece of code, notice the tilt is that much more. In fact, just as an experiment, now we can see how this whole tree looks. Let's say if I were to do t dot clear, and I were to draw, let's say, for a larger depth, maybe let's say 10. If I were to do this, notice looks quite interesting. In fact, the whole tree appears in one shot because my tracer functions, but very clearly there's a shift to the left. Now, obviously, we can try one more example. We can go and say, look, let me just reverse the situation. Let's say angle R is 20 and angle left is only 10. Again, exaggerated difference. I expect a big tilt, significant tilt to the right side. So when I run this piece of code, notice what happens. There's a significant tilt to the right side. Everything seems to be tilting right. Obviously, the gap is a bit too much, 10 and 40. So that's why the the tree is looking like this. But you get the idea that, just with understanding the basic mechanisms of how the turtle is moving, we are able to create all these variations, which are quite interesting in my opinion. As always, building projects, thinking about how we can enhance them is a great way to learn programming, and that is how we learn programming at YByte. Look at our website www.ybyte.in because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.